Good evening, Honors Algebra. Mr. Lawrence here with your flipped lesson for the weekend. We are continuing with some story problems. This time the problems will be a little different variety, and I may solve them algebraically, but I may also solve them using graphs. I may use substitution or elimination, but I may also use a graph because a graph in these situations are very important. All right, let's get to the first problem. Okay, our first problem is Bobby wants to sell some lemonade. It costs him $12 to buy all of the supplies. He decides to charge 50 cents per glass of lemonade. Part A tells us to write a linear equation that represents this situation. Well, let's think about this here. Most of the time, we tend to write our equations in slope y-intercept form, right? Y equals mx plus b. If I knew the slope and I knew the y-intercept of the story problem, I could write my equation pretty easily. Well, let's try that. Let's see here. B is the y-intercept, but it also means beginning. At the beginning, before Bobby has sold a single glass of lemonade, how much money has he made? You might be thinking he's made $12, but actually you're incorrect. It costs him $12 to buy all the supplies, the lemonade, the sugar, the cups, maybe the little sign he's going to make, the markers to help make the sign. So at the beginning, he's in the hole $12. If he sets up his lemonade stand and a snowstorm hits and not a single person comes to buy lemonade, he's made negative $12. He's in the hole $12. Okay, now I have to find the slope. Well, you see this? 50 cents per glass. Oh, that sounds like a rise and run situation. I have 0.50 for one glass. So, one glass would be 50 cents. Two glasses would be $1. Three glasses would be $1.50. Four glasses, $2, etc. Now, some of you could go ahead and just figure that out doing it that way. And that's fine, except the problem tells you to do it algebraically. So let's make a note here that we know that the slope is 0.50. 50 cents, in other words. Well, now I can write my equation. Y equals 0.50x minus 12. All right, that was pretty easy, wasn't it? All right, let's go down to question B. How many glasses does he need to sell in order to make a profit? Well, if I could find his break-even point, the break-even point. You know what? Before I do that, let's take a look at the picture, what the picture might look like. Let me get a little more space here. Okay, I've got some graph paper here, and I'm going to make sure I can show everything I need to. The first thing I'm going to need to do is plot my y-intercept. I know that's at negative 12, so I'm going to go ahead and graph that. Let's see here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay? And then I know my slope is 50 cents, or as a fraction, that would be 1/2, wouldn't it? So rise 1, run 2, rise 1, run 2, rise 1, run 2, rise 1, run 2, etc. Now I'm going to go ahead and draw this line in here. And okay, that looks pretty decent. I'm going to change that line so it stands out a little bit better. Okay, now everything. Well, you know what, one thing I should mention here is, what do you think x represents, the x-axis? Well, this is going to be the number of cups that were sold. And then y is going to be the money made. Okay, that's the y-axis. It's going to be the money made. If you think about it, the x variable is the independent variable. The y variable is the dependent variable. It depends on what x is. So which depends on the other? Does the money depend on the number of cups sold, or does the cups depend on the money sold? Well, it's an easy answer. The money depends on the cups. The more cups you sell, the more money you will make. So the money depends on the cups. So I have the y-intercept here at 0, negative 12. If I sell 0 cups, or Bobby sells 0 cups, he makes negative $12. The break-even point, graphically speaking, is right here. Right here. All I have to do is cut over and go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. That doesn't sound right. Sounds like I have a silly mistake somewhere. Hold on, let me check my math. Okay, I found my mistake. I did count fine. It's that my line was a little bit off when I graphed it. I made it thinner, as you can tell, and so therefore I'm actually only coming out to 24. I've done so many problems like this. I can tell when I've made a silly mistake like that. So it's very careful to be very precise in our graphic. All right, so this tells us this number here is 24.0. That means that 24 cups sold, he will have $0. He's out of the hole. He's paid off his $12 debt. Still hasn't made a profit though. So the answer to this question would be, how many cups does he need to sell? He needs to sell 25 cups of lemonade. If he sells 25 cups. Now that is a graphic way to do it, and it's a great way because you can see the visual. You can see what this stuff finally means. You've probably been wondering, why are we learning all this? Well, that's the y-intercept. That's the money that he's made. Okay? And over here, that's the x-intercept, and that is the number of cups it takes to make that he has sold. All right? And that's point in particular is when he breaks even. Okay, let's look at one more problem like this. Hold on. By the way, before I go on to the next problem, I did want to mention that with our equation, what was it again? Y equals 50 cents x minus 12. There is a way without graphing to solve this. I know the break-even point would be when the person has made $0, right? They'd be out of the hole. Y represents the dollars. I could plug 0 in for Y and then solve for X. Okay, so there's two approaches to this. I'd add 12 to each side. Okay, and I'm going to go ahead and convert this to 1/2 X because I'm going to be doing some math here, and I'd rather use 1/2 than 50 cents. Sorry, getting ahead of myself. That should be 12. And then if I multiply both sides by 2 or divide each side by half, I'll get x equals 24. And notice that's what we got on the graph. That's the break-even point. So the profit is still not made until you get to 25. Okay, let's look at the next problem. It says Mr. Morgan is getting ready to book a tour company for the annual Washington, D.C. trip. He has narrowed his choice down to 2 companies. The first company, get there in a hurry, charges an initial rate of $300. Initial, isn't that another word for beginning? Initial, doesn't that mean beginning? I'll bet you this is my B, my y-intercept. Yeah. And then $33 per student, this must be my slope. Yep, you got it. Okay, the second company, get there in one piece, charges initial rate of $2,000. Initial sounds like beginning. There's my B. Then $23 per student. There's my slope right there. I should be able to write my 2 equations. Let me write them even before I finish the story. Here's the second equation first. 3x plus 2,000. Why isn't it minus? Because this is all money being paid to the company. So it's not a matter of a profit. We have to pay $22,000 and then $23 per student. Okay. The other one, I believe, will be y equals $33 plus 300. Now some of you right off the bat are going, well, I'm going to go with the red one. Well, that might be a good situation, but what if there's lots of students going? It seems to me that this 33x plus 300 will end up being a larger number than 23x plus 2,000 if x is very large. If we could find out the place where they're equal or very large, then we could, equal, then maybe we could figure out the rest of it. So I'm going to start it by using substitution. I'm going to go, I should finish reading. Determine when it costs less to go with the first company, that's the red one, when it costs less to go with the second company, the blue one, and if there's ever a time when the companies cost the same. I'm going to go for the time when they cost the same. This looks like a great problem to do substitution on because y is alone in both cases. So I'm just going to substitute this in for y and get, 33x plus 300, and that'll have to equal 23x plus 2,000. I'll subtract 23x from each side, and I'll also subtract 300 from each side. Oops, I should line those up better so I don't make a silly mistake. Minus 300, there we go. And hold on one second. Okay, sorry about that. The bell rang and I had to take a pause here. But so getting back to my work, when I do this, I'll end up with 10x, and that'll equal 1,700, right? And of course, if I divide each side by 10, I'll get x to be 170. That's the equal point. That's the point of equilibrium. X is going to be my number of students. How do I know? Because it costs $23 per student, right? And remember that slope is rise over run, and rise is the change in the y's over the change in x. The students are downstairs. They're in the denominator. Students are the x value. So what this means is when there's 170 students, the companies cost the same. So therefore, I have to figure out which one is less expensive before 170 students are going. Now, for the record, Edwards will usually take anywhere from 100 to 150 students a year. So 170 students would be a little bit larger school, maybe like Willits, which is larger than us. So let's take a look at this graphically. Hold on one second. Okay, so I have a graph I'm going to make, and that'll help it pictorially. My two equations are y equals 23x plus 2,000 and y equals 33x plus 300. Now, notice on my graph, I don't think you can see that over there. On the x-axis, I did the number of students, and I counted by tens. Looks like I'm off one there, though. It looks like, yeah, things got moved. Let me see. Can I move them all? Yeah, I'm actually counting by fives. There we go. That looks better. Something must have got bumped. Sorry about that. Okay, and these numbers all got moved over there. Okay, I think I corrected everything. Now, the y-axis is my cost in dollars, and I'm counting by 300s. I showed 300 for the first one, and then I counted by 300s all the way up, but I only showed them every 3 lines after that, every 900 that is. Okay, so the red equation had a y-intercept of 300. There it is. The blue equation had a y-intercept of 2,000, and there it is, just below 2,100. Now I know that the cost is going to be exactly the same when x is 170. So what I did was I plugged in 170 for x into one of the equations. I just went like 33 times 170 plus 300. Or I could have plugged it in here, 23 times 170 plus 2,000. Either way, I'll end up with the same answer because that's where they cost the same amount. And that answer ends up being $5,910. So if they take 170 students, both companies charge the same exact amount, $5,910. All right, so let me find out where that point would be. So there's 5,700. 6,000 would be right here, so it's going to be just a hair below the 6,000 line. And so I need to place where 170 and 6,000 match up, which I think is going to be like right about there. I'm going to draw these two lines, and you'll be able to see very simply what's going on. And let me try to make it just a little more precise. It's going to be difficult to be exactly precise in this situation. And let me turn him blue so you can remember what's going on, which one's which. Excuse me. And now I'll draw the red one. Okay, and the red one will be there. Okay, now look at this. Remember that the y-axis tells you the cost. So you can tell that the blue line is clearly higher up than the red line right now. So that means for all these students, 10 students, 20 students, 15 students, 17 students, all of them, the blue one costs more. But here, at 170 students, they cost the same amount. And then, after that, the red company is worse to go with. It costs more money. All right, we're assuming everything else is being equal. So let's go back up and see if we can answer these questions. All right, so determine when it costs less to go with the first company. Well, the first is the red one, so it's best to go with the red one. And I'll be cute and write that in red. It is best to hire the first company when taking less than 170 students. Consequently, it is best to hire the second company when taking more than 170 students. And, of course, it costs the same amount. Both companies cost the same when taking 170 students. And there you go. It's really pretty easy and very useful in the real world. All right, Mr. Lawrence signing off. Let's see how I did on my time. Oh, I'm at 18:27. I'm sorry, guys. Have a great weekend. Talk to you Monday.